Okay, everybody, we're going to look at parallel lines and the angles that are related to them. Okay, we prove alternate exterior angles are congruent when a transversal intersects two parallel lines. Now, we talked about this briefly. Alternate interior angles. They are on opposite sides of Timmy the transversal, and they're inside the imaginary box. So alternate interior angles, D and F, C and E, they're on alternate sides and they are inside the little box. If our two lines are parallel, which these guys are, you see these little caret guys? So our two lines are parallel, then alternate interior angles are equal. Okay, everybody take that in for a couple of seconds. Now, you also know that corresponding angles are congruent if our lines are parallel. Corresponding angles are angles in the exact same position on a different line. So if you notice, angle A matches angle E. They're in the exact same position, but on a different line. Look at angle B. It's to the right of the transversal, above the line. Angle F to the right of the transversal, above the line. They are corresponding angles. Okay, and then you know vertical angles are equal. So you can use this to walk things down, is what I call it, and show that alternate interior angles are equal. Also, if they give you one angle of this diagram, you have everything else. If you have one angle of a set of parallel lines cut by a transversal, you have everything else. Now look at this one. And again, parallel lines cut by a transversal are your friend. Notice angle G is 65 degrees. That gives me everything else. I'm going to label it. Angle G is 65 degrees. Okay? That hands me everything else. I have to learn how to write, but it hands me everything else. Angle E, do we know what that is? Say 65, because of vertical angles. Very good. Now, F and G, what do they make? They make a linear pair. So what is the measure of angle F? 180 minus 65. 180 minus 60 is 120. 120 minus 5 is 115. Now, we know corresponding angles are equal. Okay, angle F and angle B are corresponding angles. 115. Oh, again, I have to learn how to write, but you'll forgive me. That looks like a 45. I'll redo it. Excuse me. 1, 1, 5. All right, now basically you have everything else. These two make a line, 65. These two make a line, 115. Or vertical angles. So we could prove vertical angles with this. We could prove a million things. 65. 115. Now I want you to look at stuff. You all looking? Okay, so watch. 65, 115, 65, 115. So now, corresponding angles, D and H, congruent. Corresponding angles, A and E, congruent. Okay, same side interior angles, add to 180. Add to 180. Same side exterior angles, add to 180. Add to 180. Okay, alternate exterior angles, congruent. Alternate interior angles, congruent. This gave us everything. Now, with what we just did come the theorems, okay, or postulates. Okay, if the lines intersected by a transversal form congruent corresponding angles, then the lines are parallel. And if you remember before, we learned if the lines are parallel, corresponding angles are equal. This one says if corresponding angles are equal, then the lines are parallel. Here, if alternate interior angles are congruent, then the lines are parallel. Before we did if the lines are parallel, alternate interiors are congruent. So we're doing kind of the opposite right now. Okay, alternate exterior. If alternate exterior angles are congruent, the lines are parallel. If consecutive, same side, interior or exterior angles are supplementary, then your lines are parallel.